All right, everybody, so let's do an introduction to logarithms. And for short, we usually say logs. All right, so let's take down some notes. So first of all, like if I asked you, what power do you raise 2 to get 4, you would say 2. Or what power of 2 is 8, you would say 3. But if I said, 2 to what power would be 6, right? Well, now we have a problem. That's something you don't know. And the answer is going to be log base 2 of 6, okay? And so let's talk a little bit more about that, okay? So here's a little definition for you. B to the power of x equals y if and only if log base b of y equals x. So notice this conversion here, and notice how I read it too, right? We'd say log base b of y. Okay, and so there you can see we have a couple of examples. So let's just practice converting from, this is what we call log form, into its exponential form. And so for the first one, if we had log base 2 of 16 equals 4, we would say 2 to the 4th. So the number, that's the little number, the subscript number, that's the base. And then what's on the other side of the equal sign is the exponent. And then what's being logged is actually the solution. And notice that 2 to the 4 equals 16, that makes sense. Let's do the others. Okay, so there you go. And doesn't that make sense? Anything to the power of 0 is 1. Okay, 12 to the 1 is 12, and 1/4 to the -1 power. Remember, a negative exponent, it flips it, or it takes the reciprocal. Okay, and a couple more examples now, going from exponential form to logarithmic form, and it's the same thing, just going back the other direction. Okay, so let's just take a look at these two rules, and now let's just practice evaluating. So now on these ones, you're asking yourself, what would go on the other side of the equal sign? 4 to what power is 64? 5 to what power is 0.2, which is 1/5. 1/5 to what power is 125, and 36 to what power is 6. So think about those for just a second. And then there you have your answers: 3, -1, -3, and 1/2. Okay, and so, oops, let me hide this for a second. Okay, and so you can see here, we also have, we talked about the natural number e, and e is so special that it has its own logarithm. It's called the natural logarithm, and it's ln, not log, okay? And so when the base is e, we use natural log, ln. Okay, and so let's just practice computing a couple. Let's take out our calculators and go ahead and find our log button and our natural log button, and go ahead and practice and make sure you get these answers. Okay, and then why don't you go ahead and pause this real quick and give these ones a try. See if you can get these so far based on what we've talked about. So please pause, give these a try. Here are your solutions when you're ready. Okay, all right, and so let's move on here and talk about inverses, okay? And let's do a problem with inverses. So let's practice finding the inverse of this exponential function f of x equals 4 to the power of x. So remember, logs and exponentials are inverses of each other. So, remember your steps for finding an inverse. You change f of x to y, you switch the spots of the x and the y, and then you want to solve for the y in its new spot. So let's do all those things, right? So there, we change them, we convert to log form, and now we have the y by itself in its new spot. And so we're going to say f inverse is log base 4 of x. All right. And now why don't you go ahead and pause and go back to what we've been talking about so far and give these ones a try. And when you're ready, there's your answers. All right, good luck, everybody. Let's go ahead and get to the practice set. Let me turn this off here.